All right, so let's begin by graphing y equal 1 over x. So 1 over x looks like this and like this. Then we're going to graph x equal 4. So x equal 4 looks like this. And then we're going to graph y equal x. So y equal x looks like this. All right, so finding the area bounded. This is one of them that is so easy to make a mistake on. I want to make sure, put a star by here to think about where the area is. There is no x or y axis involved. So to include the red, the green, and the blue, I see this is the area bounded. All right, so I'm going to build a rectangle in here. So I can see the top of the rectangle and I can see the bottom of the rectangle. So the area is going to be top function, which is x, subtract the bottom function, which is 1 over x. dx integration, thickness of the rectangle is dx, that wide, dx thickness. And I'm going to start building the rectangles here and end building them here. So I'm going to end at 4. And let's think about where 1 over x equals x. So that's 1 equal x squared, x equal plus or minus 1, but you can just see that it's going to be just the x value of 1. And you didn't need to go solve it. You could probably just use your common sense to think about where they intersect. All right, let's look at y equal x cubed, which looks like this. And then I've got y equal negative x, which looks like this. And then I've got y equal 9, which looks like this. All right, so finding the area bounded between those three graphs is right in here. All right, so if I build a rectangle, there's a top function, there's a bottom function. But as I investigate, the bottom function is changing as I move over into quadrant 1. So I'm going to have area 1 and integral for area 1 and integral for area 2. So the integral for area 1 will be the top function minus the bottom function. So the top is the 9 and the bottom is the negative x. And then the integral for area 2 will be the top function of 9 and subtract off the bottom function of x cubed. All right, so let's go back and fill in the details. So I need to find out where they intersect up into 0. I can see that's where it's going to stop. So I'm looking to see where y equal 9 intersects with negative x. Well, that's going to be negative 9. So negative 9 is this x value here, negative 9 to 0. And this integral here, I'm going to start at 0. I'm going to go to this x value where 9 intersects with x cubed. And so that's going to be 9 to the 1/3 power. And that's fine to leave it like that. All right, so let's look at this one. So y equal x squared. Get a quick graph here, and then you start to think, wait a minute, I think x to the 4th is very similar, so let's stop and think a minute, and let's just kind of expand what we know. So I'm going to zero in between 0 and 1 to find out what's happening. So if I'm thinking about x to the 4th, it's also going to cross at 0, and it's also going to cross at 1. I'm curious to find out what's happening in between, like at a number like 1/2. So if I have the number 1/2 into x to the 4th, it's going to be a very small number, whereas the x equal 1/2 into x squared will give you 1/4. So the red x to the 4th graph will be below the x squared graph. Okay, so I see two areas, so I like to double. So I'm going to double the area that's there in quadrant 1. So the area will be 2 times. I'm going to start at 0 and go to 1. And the top function will be x squared and the bottom function x to the 4th. All right, so let's look at e to the negative x, which you know looks like this, crosses at 1. Then I've got the line of y equal 1. So y equal 1 comes across looking like this. And then I've got the graph of x equal 3 here. So be really careful that you're looking to find out where the area bounded is, and that's in here. You're not using any of the x or y axis. So the area will be the top function which is the line y equal 1, subtract off the bottom function negative x, dx, thickness of the rectangle is dx. Then I'm going to be building rectangles from 0 to this line here, which is x equals 3. All right, so let's look at tangent of x. You know what tangent looks like. You know that it's got asymptotes. Asymptotes are a really big deal. All right, so x equals 0. X equals 0 is this. Need to know that. And then y equal 1 looks like this. So where is that area bounded, contained between all three of these graphs? Right in here. All right, so let's build our rectangle. So there's top of the rectangle, bottom of the rectangle. So top of the rectangle is 1. Bottom of the rectangle is tangent of x, dx. So I start building rectangles here at 0, and I cannot go to pi over 2. I'm looking to find out where they intersect. So where does tangent of x intersect with 1? Well, this is a unit circle question, so what angle would that be? That would be pi over 4. All right, one last one. Cotangent. Cotangent looks like this, has asymptotes as well, right? Here and here, so crosses at pi over 2, and the asymptote is at pi here. So they just want me looking between 0 and pi over 2, so here to here. And then y equal 1, so let's do that one in a different color. Y equal 1 looks like this. So between x equals 0 and x equal pi over 2, let me just use a different color here. X equal pi over 2 and x equals 0 is not really involved there, so this is kind of giving me this area here. So this area here that's bounded, I want to find that area. So here's my rectangle, top of the rectangle, bottom of the rectangle. So my area will be y equal 1 is the top function. Subtract off the bottom function, which is cotangent of x, dx integration. And then I'm going to end building the rectangles at pi over 2. I can see that, but I need to find out where this beginning point of the integral is. So this will be where cotangent of x runs into 1. So this is cosine over sine equaling 1. So thinking about when that happens, that's going to be the angle of pi over 4.